In the question number 41, the expansion of unit mass of a perfect gas at constant pressure as shown in the figure, then B and A. So question is asking to us what is the meaning of B and A. So if I go for the diagram or graph, then we can find, and temperature is in degree Celsius. Volume of the gas B becomes 0, right? At absolute temperature in degree Celsius, it will be negative. We know. Therefore, A is volume and B is temperature. Simple as that. So you can find option number third will be the right choice. So let's move on. Question number 42. Internal energy of n moles of helium at temperature T1 in the question number 42 of 2n moles of oxygen gas at temperature T2 Kelvin, then value of T1 and T2. So this is another good and basic question. You can solve by using a simple calculation because internal energy is given by 1 by 2 F N R T, where N number of moles, R ideal gas constant, and F is the degree of freedom. So if I take for both situation 1 by 2, first one N1, degree of freedom F1, temperature T1 and R. For second scenario 1 by 2, N2, F2, T2, R. Now if I put the values, so we'll get number of moles N into 3T1 on the right hand side 2 times of N, 5 times of T2. Because 1 by 2 will cancel out, and helium is monoatomic and oxygen is diatomic. So you will place the value of degree of freedom accordingly 3 and 5. So on solving, I have the ratio T1 upon T2 will be 10 by 3. So by this calculation, I can say my option number 2 will be the right choice. So let's move on. Question number 43. In the question number 43, if E is the average rotational kinetic energy per mole of diatomic gas at the absolute temperature T, then the universal constant R is given by, because average kinetic energy per mole per degree of freedom is given by 1 by 2 RT. We know. So I am going to write the rotational average kinetic energy per mole for diatomic gas. So that is 2 times of 1 by 2 RT. So that will give you only RT. And according to the problem, this RT is equal to E. Because question says E average rotational kinetic energy, that is E, per mole of diatomic gas at the absolute temperature T. You can write this equation. By this equation, R is equal to E by T. And I need this. So question number 43, the option number third will be the right choice. Let's move on. Question number 44. In the question number 44, 1 mole of monoatomic gas gamma this mixed with 2 moles of polyatomic and gamma is given. The value of gamma for the mixture will be, and gamma is adiabatic constant. Okay. Formula for mixture of the gamma, we know N1 plus N2. I would like to suggest you can memorize this. Gamma for mix minus 1, and that is equal to N1 upon gamma 1 minus 1 plus N2 and gamma 2 minus 1. And gamma you can solve 1 plus 2 by F. F is the degree of freedom, 2, 3, 5. So if I put the value of number of moles as per the question 1 plus 2, gamma mix is our requirement, and 1 upon gamma 1 as per this formula we will write 5 by 3 minus 1 plus 2 upon 4 upon 3 minus 1, right? So when you will calculate, because gamma mix is only unknown, so you will find 7 upon 5. So this is how you can deal this question. So option number 1 will be the right choice. Let's move on. Question number 45. In the question number 45, RMS speed of molecules of an ideal gas is V0. If pressure of the gas is half but temperature is kept constant, then RMS speed of the gas molecules will be. We know that root mean square speed of gas molecules directly proportional to the absolute temperature. So temperature of the gas remain constant. Therefore, RMS speed will remain same. So my option number 4 will be the right choice. So thank you, and we will meet again. Thank you.